Hi guys. So you can find it on UEXED.com, and we are dealing in right now with physical sciences. So the courses that we are going to cover in physical sciences are basically JEE, NEET, NET, GATE, right? These are the courses that we are going to cover right now. So currently, you can always write us to basically, this is the website where you can find us. So currently, that's the information for us. So your batches are started from 1st of May. So you can join us over here. So what we are studying right now, statistical mechanics, right? That's what we are looking into. And in statistical mechanics, we have seen a few things. Number one is basically looking the second law of thermodynamics, second law. And through second law, we have seen entropy. And we have seen the basically the how you can define entropy, like through the Boltzmann way, like it's associated with the logarithmic of the number of microstates available to system, right? That's what we have looked into it. So now let's delve into these concepts more. मतलब जानना जरूरी है कि क्या exactly इसका मतलब है. We have seen there are two definitions, right? तो सबसे पहली definition क्या थी? Number A, if I say, it's like Kelvin statement, and number B is for Clausius statements. So these both statements were equal, right? Kelvin's and Clausius statements, and the statements were that the nature proceeds from order to disorder. Those are the statements. Nature proceeds from order to disorder. So this is kind of order disorder sort of transition. That's what we are interested into. Now let's look into a few things more. So the interpretation, we also looked a few interpretations, right? Kya interpretations the? Number one, that you can always correlate it with order disorder sort of thing, right? Or a disorder kind of approach. Number two, you can connect it with the information approach. So what we do in the information theory, that's both these approach are equally valid, but in case of, I said that looking तो ऐसा हुआ था कि like what we talked, हमने बताया कि like there are procedures or processes which proceeds in a one way, they are one way arrow, right? For example, if a container में gas भरी है and you divide the container something like this, or फिर you remove this wall, you see there is a spontaneous flow of gas molecules, and the final state will be something where molecules are going to occupy whole region, right? So these process, I said these processes are very much like a spontaneous in nature. These processes are spontaneous in nature. What that means that they proceed in just one direction, right? So looking these processes, so we associated a quantity called entropy, and says entropy is the one that drives this sort of process. And so process may quantity have which basically govern the, which is the basically law, all right? जो कि law है, right? It's a very fundamental quantity which changes in all these processes. That's called entropy, right? तो दूसरा इंटरप्रिटेशन हमने देखा इंफॉर्मेशन थ्योरी से कि there's a kind of, we can think of the information that is lost in these sort of systems. In the first approach, that Kelvin Clausius statements, entropy always positive, right? In Clausius, Kelvin's and Clausius approach, this is always positive. But in the second one, like entropy, it also decreases, right? It also decreases, that is turns out to be negative sometime, and this is called Boltzmann. Boltzmann theory. Probability, we will look the H theorem and those sort of then this thing is going to be complete more now. तब ज़्यादा समझ आएगा वहाँ पे. But then we are looking into few things. Number 1, probabilities क्या हैं? Right, and we are looking into few things. Number 1, हम जो देख रहे हैं वो basically that was formulated by Kolmogorov. Kolmogorov's approach. Right, the Kolmogorov approach, this came in 1930. In Kolmogorov approach is called basically axiomatic approach. And axiomatic approach, what it requires to define a probability, right? In axiomatic approach, Kolmogorov equally speaking of. So, उसमें how do you define the probability, right? तो इसमें define करने के लिए सबसे पहले you know that we need to have a sample space, right? So how do you define a sample space, right? Sample space could be a space of, let's say, so this could be very much, let's take an example. So dice का example ले लेते हैं. So dice में you know dice has 6 faces, right? 6 faces. So what will be the sample space in this case? I said if S denotes the sample space, let's say not S because S we are defining as entropy, let's say S1 now, right? Let me write S1. So sample space क्या होगा? Dice में 1, 2, 3, 4, 5, 6. This is a sample space for a dice. And what sort of sample space for a coin? For a coin. Write down the sample space. So coin के लिए, you know that there are 2 possibilities, head and tail in case of coins, right? So what will be the sample space? H, T, right? This will be the sample space for a coin, right? So then we also see that what could be an event. So let's define an event. Event could be a single throw of a dice, right? This is a very possible event. Or let's say you can also define always a collection of event, right? So collection क्या होगा events का? जैसे मैंने बोला कि dice को मैंने throw किया and I want some set of outcomes which have all even number outcome, right? तो dice को अगर throw करोगे तो like 1 आ सकता है, 2 आ सकता है, 3 आ सकता है, 1, 2, 3, 4, 5, 6, anything can come out, right? So now I choose that let my outcome be something like polarized in such a way that I just only get 2, 4, and 6, right? So the collection of event are something like, which I can again define a set, let's say 3. So something like this 2, 4, 6. This could be a collection of event. And there's one more thing that how do we associate probability of each outcome? तो मतलब अभी हर जो outcome है उससे associated probability कैसे हम define करते हैं? Okay, so we said that कि हम each outcome, for example, अब the dice को throw किया तो 1 outcome आ सकता है, right? 2 आ सकता है, तो for each outcome there is a probability associated with it, right? And those probabilities are basically is the probability that we have seen that for, if let's say E is my event, so the probability for an event E is always going to be something like this. And the event which is impossible in nature, impossible event, we say that the probability will be 0. For event which is certain in nature, we see that the probability is always 1, right? So that's what. And and we also saw one more law that if let me write in next slide, if A and B are events which are mutually exclusive. So the probability would be how much? For combined probability would be the sum of individual probability for disjoint or mutually exclusive event, right? This is also, you have to know that. So let's take an example. What do you mean by what So mutually exclusive events. Right? तो म्यूचुअली एक्सक्लूसिव इवेंट्स क्या होते हैं? तो मैंने बताया कि राइट व्हेन यू थ्रो ए डाइस, लेट्स से you collect some incidents और एक सेट बना लेते हैं उन इंसिडेंट्स का, एंड आई से द सेट इज समथिंग लाइक आई विल डिनोट इट बाई S4. दिस इज माई सेट है, और ये सेट उन सभी इवेंट्स का सेट है जो कि इवन ऑन ए डाइस. तो मतलब कहने का मतलब डाइस पे जब भी 2, 4 और 6 आ रहा है, आई डिफाइन अ सेट कॉल्ड S4 which has the element 2, 4, 6. Right? Now let's consider a set, or maybe in this case I would like to call it SE. E stand for even. So let me call this set as SE. And now I can again define a set called SO, where O stand for odd, which would be something like 1, 3, 5. So you can see that basically SE and SO are basically mutually exclusive. Right? That means that is when one appears, other does not. Right? Or maybe they could be disjoint too. So now how you define the probability, right? So for example, let's do a question. Now I want you to throw a coin, a coin ko chalo, right? And you saw that what will be the possible outcome, right? So the possible outcome, or I said the sample space for a coin will be something like head on 10, right? Head or tail. So there is also probability associated with each outcome. That's what we are looking into, right? You need to define a sample space. So let's recall those first laws. Number 1, define sample space. Let's look at the second law. Define events, define event and probability associated with each event. Right, so define event. Now the event, for example, I say what will be the probability for an event which have a head. So you see, there's a one event of a head can appear in just one event, right? Because there are only 2 events that can happen. They're either head or either tail. This is an event and this is an event, right? Now either these 2 events can happen. And if I want to ask you that क्या होगी probability for an event, for an head event, right? इसकी probability क्या होगी? You know that my sample space consists of basically 2 events, and there is only, so basically the number of total event that would go here, if you want to calculate the probability of one event, and then the number of times that event is appearing, right? That's a basic idea. So the head event is appearing, you see, just a one time, right? And the total number of is 2. So you can see that the probability turns out to be 1/2, right? So now I give you one more question. ऐसा करके क्वेश्चन ये है कि कैलकुलेट the probability of events greater or equal to 4 in a throw of dice, right? Calculate the probability of events greater than or equal to 4 in a throw of dice. That's what the question is. So how do you write the answer? You first define the sample space. That's the idea. What will be the sample space for a throw of dice? So SD That 1, 2, 3, 4, 5, 6, right? So now the what would be the events, right? For probability of events greater than, so events, how the events are defined? 4, 5, 6. So you see, any of these can appear. So there are three possible ways that event greater than 4 can appear, right? And the total, what are the total ways? Total ways are 6. So what will be the probability? What will be the probability of this event greater than or equal than 4 is 3 by 6, right? Right. So these definition, these approaches are called as classical definition or maybe a priori one. A priori one, where each event has a priori probability which is equal for any sort of events, right? So let's stop it here. I mean, you looked all the basic concepts of the probability. Then next time we will discuss more challenging problems, and we will, which will lead into more statistical description, which we are requiring right now. Thank you for today's class.